Hello students, good morning to everyone. So today we'll discuss quantitative analysis. That means what happened? So estimation of elements which are present in an organic compound. For example, so nitrogen percentage, carbon percentage, sulfur percentage, phosphorus percentage that we'll discuss today in detail in this class. Okay. So if you see the organic compound naturally occurring, right? Suppose a quantitative analysis of a compound is very important in organic chemistry, right? It involves estimation of percentage composition of various elements by a suitable methods we will do. For example, suitable methods means what we can able to see here. For example, Lebig's method, Lebig's method. In this method, what we'll do, we'll try to find the percentage of carbon and percentage of hydrogen. Next one, what happen? So, Dumas method will do Dumas as well as Geldal method. Geldal method also will see for the estimation of nitrogen for a percentage of nitrogen. Then we'll see the curious method. Will see curious method estimation of halogen. Okay, halogen, phosphorus, and sulfur. This will see. Then if you try to see the oxygen, so the percentage calculation of oxygen, there will be have no direct method, but we can use the Lewis method. We can use Lewis method. Lewis method we can do to find the percentage of oxygen. Okay, so these are the methods that we are going to discuss today in this class. First one, Lebig's method. So here, Lebig's method, what will happen in this case? Lebig's method. In Lebig's method, generally what happens? So we will take unknown hydrocarbon. Will take it right. For example, let us take here. So we have taken unknown hydrocarbon CX HY plus X plus Y by 4 X plus Y by 4 O2 gives rise to XCO2 gas plus Y by 2 H2O liquid will be forming. For this unknown hydrocarbon undergoes combustion, right? So in this case, what will happen? We will try to find out the percentage of carbon. For example, if I want to get the percentage of carbon, no, what will do now? So atomic weight of carbon, right? Suppose here percentage in the case of carbon dioxide gas is coming in a given carbon dioxide, right? How to find out the percentage of carbon? So atomic of weight of carbon will be 12 and molar mass of carbon dioxide is 44 we will be having. How? Carbon 12 plus oxygen 16 into 2. That becomes, so 12 plus 32. You will get the 44 will come. Okay. Into weight of CO2. Weight of CO2 gas divided by weight of organic compound into 100. If I do this particular calculation, so we will get the percentage of oxygen. Will get how much percentage of oxygen present in a given organic compound. Same thing if I do for the percentage of hydrogen, no, that means hydrogen what happened from the water. So water is there, right? Molar mass of water, molar mass of water. So 2 1 hydrogen 1 mass, 2 hydrogen 2 plus 16. So it become 18 is coming, right? How many atoms are there? 2. That means 2 atomic mass of hydrogen 2 by molar mass is 18 into same weight of H2O liquid divided by weight of organic compound into 100. So if you do like this, we will get the both carbon percentage as well as hydrogen percentage will be getting. This process will try to see how to estimate, how to find out the this method by the experimental method we can see here, no? Right? For example, see here. Huh. So this is a setup for the given particular process of Lebig's method. Now we'll try to understand each and everything, right? So suppose what happened here now. So we have taken a pure dry oxygen. We are sending to the this particular container, right? Now here what happened in this bowl is there. No, this bowl will be having the sample is there. The kind of platinum bowl we have taken. Now we are providing the flame. Now, upon providing flame, dry oxygen we are passing. So, what happened now? Combustion taking place, right? When combustion taking place of hydrocarbon, it will release the carbon dioxide as well as water. Now, here this will be what happened? Copper, cupric oxide pellets we place it, right? Now, whenever carbon dioxide is coming, water is coming. First, what happened? Calcium hydride, calcium chloride. We are placing one YouTube manometer here, right? Another YouTube manometer, we are placing the KOH. What the KOH will do? It will try to observe the water which is producing from the carbon dioxide. Okay. Now, so here this will be the water observing, right? This will be this will be the carbon dioxide observing CO2, right? Observe the carbon dioxide and it will form the K2CO3 will be forming, right? Now here what happened? Calcium chloride will be absorbing the water. So initially how much mass of calcium chloride is present and after absorbing the water, how much mass increasing. Same scenario we will do for the case of in the KOH CO2 absorption. So by doing this one, we can estimate the CO2 as well as H2O. Now if we see the process like a clear picture way, so here what happened now? First method is combustion of organic compound here. You can see at the top right, right? At the top right, what happened now? Combustion of organic compound first. Combustion of organic compound. A known mass of compound is heated with the excess dry oxygen O2, right? Heated where cupric oxide we are eating, right? Carbon, cupric oxide forming carbon dioxide plus CO. Now 2H2, right? Hydrogen, cupric oxide, water is forming, copper will be separated. Now, so here you can see this one, this is the bowl that we are giving like the reaction taking place, combustion, right? Here we have taken two U2s. One will be having the KOH, other will be having the CaCl2. Both will be having the observer of CO2 as well as water. Now, after that, what happened? CaCl2 observing water forming as a hydrated CaCl will be forming. Same thing, KOH will be observing carbon dioxide forming potassium carbonate will be forming. So, before how much mass, after observing how much, the difference in the weight, we can able to get the percentage of carbon from this method. Now, how the question can able to frame on this? Suppose, let us take here example question will be like this. Suppose we have what the question was talking about and complete combustion and a complete combustion of 0.246 of an organic compound gave 0.198 gram of carbon dioxide. So here given data I'm writing organic weight compound how much they given. So 0.246 grams, right? Then weight of carbon dioxide also they given, right? Weight of carbon dioxide they given how much? So they have given 0.198 gram. Yes, right? Now they also given weight of water also they given how much? 0.1014 gram. Then we need to find out the percentage of carbon. What is the formula we have? Just now we discussed, right? So where we discussed, you can see this formula we have to apply there for the case of percentage of carbon. Now, atomic weight of carbon 12, molar mass of carbon dioxide 44 into weight of carbon dioxide how much? 0.198 by molar again weight of organic compound 0.246 gram into 100. So after solving how much will get here? We'll get the 21.9 percentage of carbon. Percentage of carbon how much we got? 21.9. Okay, now what we'll do, we'll try to find out the percentage of hydrogen, same thing. Percentage of hydrogen what we have? So 2 mass by 18 molar mass into weight of water, that will be 0.1014 by 0.246 into 100. So how much are getting here? 4.57 we are getting the percentage of hydrogen. So is it clear? Yes guys, it's clear. So what we got here? Percentage of carbon 21, hydrogen will be 4 point. So given option will be A is the correct option for this question. Chalo, next question, next topic what we have, estimation of nitrogen. Estimation of nitrogen is most important. Most oftenly this question is correct. Number of times the question is framing either a Dumas method or a Geldal method. From the Dumas method, numerical only basically they will ask. From the Geldal method, theoretical question they can able to frame, right? As well as numerical. I will let you know from where the theoretical question can able to come. Numerical we know, right? Only the formula based question the people will able to frame on that. First, what we'll do? First we'll try to see the First, we'll try to see the Dumas method, right? First, we'll try to see the Dumas method. Okay, so first, let me explain the relation for percentage calculation of nitrogen. Then we'll come to the process diagram, right? So here, what happened? We'll take unknown hydrocarbon. First, estimation of nitrogen by Dumas. Dumas method. Okay, for percentage of nitrogen, we are discussing. Now let us take CX HY, NZ we have taken. Okay. Now this will be again where treating with the cupric oxide. 2x plus y by 2 Cu will be giving the XCO2 gas plus y by 2 H2O liquid plus Z by 2 N2 gas. Then what we left out here, 2x plus y by 2, then Cu will be forming. So this equation for the estimation of nitrogen. So finally what happened? Oxides of nitrogen plus cupric oxide is converting into N2 gas, right? Producing this one, right? From here we need to find out the percentage of nitrogen. Let us see. So here basically what happened, we will be having this relation P minus P1 into V1 by T1 is equal to P2 V2 by T2. This relation has come from the where? This one. P1 V1 by T1 is equal to P2 V2 by T2. When number of moles are same, then we can able to use this one, right? From the ideal gas equation, we can able to got this one. Here, what actually this parameter represent that? What actually these parameters represent? So here, P is equal to what we have. P is equal to so P is equal to pressure of moist gas. Pressure of moist. The units should be mm of Hg. Pressure units mm of Hg. So what we have, P1 is equal to, so aqueous tension pressure. Aqueous tension pressure. Aqueous tension pressure. Then T1. So V1 is equal to what happened? Volume in ml at T1 temperature. And what is T1? It is the initial temperature, no? Initial temperature, how much they given? It should be also in Kelvin. Then what else we have? T2. So guys, so this particular right side part is there, no? This will be taken as a STP condition. As STP condition, right? Now, so here P2 is equal to pressure at STP, how much? 760 mm of Hg we can take, right? Now T2 how much? T2 will be So 273 Kelvin temperature. Then volume is equal to, we need to find out. Why? We know, right? At STP condition, volume will be 22.4 liter. But when number of mole of a gas is 1 mole. But we don't know how many moles of N2 is producing, right? This moles of N2 we don't know. So for unknown number of moles are coming. For that case, at STP volume we should not take 22.4 liter. Now, after finding the volume, then what am I going to get the percentage of nitrogen? No. Then how to do now percentage of nitrogen? Percentage of nitrogen is equal to 28. What is the 28? Molecular mass of N2 by I'm converting volume into liter 22400 ml into, so here volume it is should be in ml divided by weight of organic compound into 100. So by solving this data, I will get to know how much percentage of nitrogen is present. Now we'll come to the process. What will happen in this case? See here carefully. So here what we have. So in this method, nitrogen present in organic compound is converted to N2, that we have seen, right? Oxides of nitrogen, copper is converting into cupric oxide, right? Now the weight amount of organic compound is heated with a cupric oxide in the atmosphere of carbon dioxide. Okay. The carbon and hydrogen present in the compound are oxidized to carbon dioxide as well as water as well as nitrogen will be pre-state. Now, some of the oxides formed are reduced to free nitrogen. So why we are using copper gas? Here we are using the copper gas, no? Copper gas we are using because to convert the unwanted and nitric oxide. Suppose let us take here, we'll be having like this. Sorry for this. So suppose if I have this kind of gases we're getting, let us say NOx gas are forming. To convert this NO gases into N2, copper gas we are using. Copper gas we are using. This copper gas converts this oxides into free nitrogen. For that purpose, copper gas will be used in this condition. Okay. Now, the mixture of gases produced collected over a caustic potash solution, right? Keyword solution which observe the carbon dioxide. Nitrogen is collected in on the upper part of the nitrometer. Look at here, we are passing the CO2 here. Why we are passing CO2? Because other gases should not come interfere in the process. Now here what happened? This entire will be furnace. This entire will be furnace. Now here we have copper gas. You know, right, what the copper gas will do? This one. Copper gas will do this kind of process. Conversion of unwanted oxides into N2. Now, then what happened? Here we have taken the mercury. Here we taken the aqueous solution KOH. When N2 is collected here, no, that's why we are writing as a, this will be kind of moisture form. So there we have taken pressure of moist gas. That means this total pressure of the moist gas. Then what is P1? This aqueous tension, how much pressure, right? If I take the total pressure minus aqueous tension, no, then I'll get the how much initially, how much the pressure of N2 will be present, right? So now by using this condition, we can able to find out the this particular relation, okay, percentage of nitrogen, right, as well as this volume of N2 we have to find out. Now you can see in the flow chart directly given organic compound we have taken, right? Now we are heating the organic compound, CO2 gas, H2O, N2 forming, along with that NOx. NOx is forming, right? NOx forming. Now to convert this NOx into N2 form, we are heating that compound into copper gas, right? So then what happened here? Combustion tube, excessive CO we're passing, right? So then what happens? KOH observe the CO2 gas, pure nitrogen collected where? Yeah. So there we are calling as a, so moist pressure. Okay. So this is a process here also given complete clearly. So go through this one. It will be Easy. Main motto is what we have. We need to find out the percentage of nitrogen using Dumas method. Okay. Now we'll see on this one relation. So how to get the answer for that question. So here formula also I think represented here from formula, right? As well as percentage of nitrogen. So here this represent the weight of organic compound. Weight of organic compound we have this one. This is volume, right? In ml. What is this one? Molecular mass of N2. This is volume 22.4 liter. We converted into ml. 22400 ml. Now see the question. What the question was saying is that in Dumas method, estimation of nitrogen. In Dumas method, estimation of nitrogen 0.3 gram of organic compound they given. So here given data, weight of organic compound they given 0.3 grams and V1 they given 50 ml they given. T1 how much they given 300 Kelvin. So here pressure of moist gas how much they given. So that is P they given as a 715. Aqueous tension pressure they given as 15. Right? I think this is the data we have. From that we can able to find out first P minus P1 into V1 by T1 is equal to P2 V2 by T2. So here P minus P1 how much? 715 minus 15 into V1 how much? 50 ml. Don't need to convert any ml to liter. Then temperature how much? It will be 300 Kelvin. And pressure P2 will be at STP, that is 760 mm. V2 we need to find out. T2 how much? 273 Kelvin. So after finding how much I'm getting the volume, we'll get the volume 41.9 milliliter. We are getting this one value. Now this value substitute in the percentage of nitrogen is equal to 28 into 41.9 divided by 22400 into weight of organic compound into 100. So after solving this one, we'll get the 17.4 percentage. That is given option will be B is the right answer. This is how we have to approach the questions. Now we have Geldal method. So Geldal method, what will happen in this case? Now we'll try to see the Geldal. So the compound containing nitrogen is heated with a concentrated sulfuric acid first. Then it will form ammonium sulfate will form. Nitrogen in the compound gets converted into ammonium sulfate. Now again the resulting mixture again it is heated with the excess amount of sodium hydroxide. Then ammonia gas will be evolved. After ammonia gas is evolved, again heat with a standard solution of sulfuric acid. Then ammonia will be produced. Ammonia sulfate will come. From the ammonia sulfate, we can get the N2 gas, right? So this is how we can able to find out the percentage of nitrogen. Now you can see here, first organic compound we have taken, right? First organic compound, heating with the sulfuric acid, ammonia sulfate will be formed. It is kind of impure form. Now this ammonia sulfate, if you treat with the excess amount of sodium hydroxide, so here what happened? NH3 gas is producing. This NH3 gas, again when you treat with the sulfuric acid, it is producing the ammonium sulfate. This ammonium sulfate, excess amount of heat if you give, no, what happen? N2 gas will be producing. This N2 gas percentage we need to find out. Okay, now let us see how to find out the percentage of nitrogen in this case. Alright, percentage of nitrogen is equal to 1.4 into normality into volume in ml divided by what will happen? Weight of organic compound. So this is the relation that we can use in the case of Geldal method. Now we'll try to find out the each parameter clearly. This will be weight of organic compound, this one, weight of organic compound we have, weight of organic compound we have. Okay. Now, okay. Yes. Now, what is the n here? N is nothing but normality. What is the V? V is represent the volume of solution. Volume of solution. Now, look at here. We need to know the relation between the normality versus molarity. This one. So here, this is the normality. What is this one? This is molarity. This is molarity. Whereas this one is the valency factor. Valency factor. Right? Valence factor for acids, number of H plus ions which are coming. For bases, number of OH minus are coming. So here is the process. Clearly, it is in diagrammatic model, so we can understand much better way. So here we have taken the Geldal flask. In this only we have the organic compound is present here. Okay. Now, so this will be transferring into the solution, right? After treating with the sulfuric acid in a copper sulfate, sulfuric acid as well as copper sulfate treating, this solution will transferring into here in this. Treating with the excess amount of sodium hydroxide. Now what is forming? Ammonia. Ammonia again you are treating with the sulfuric acid forming ammonium sulfate. Now that from that upon heating you will get the N2 gas is forming. That N2 gas will be here, will be collected here. Okay. So finally here what happened? There are some limitations are there. What limitations here is Geldal method cannot give test for all. It will give only for this cases. For example, Geldal method will not give test for all the compounds. For example, let us take here. So Geldal method will not give, will not give, right? For example, so NO2 group present in the compound, right? Diazo compound in the present in the compound, right? Diazo compound in this compound, right? A ring in a, right? Nitrogen in a ring. For example, pyridine, right? If I take a pyridine, no, in a pyridine, nitrogen present in the ring. So this also will not give. Phenolene also will not give the test for this one. Phenolene also will not give the test for this one, like this. So in this case, what happened? The people will not able to convert and this compound into ammonium sulfate. If it is not able to converting into ammonium sulfate, the particular one cannot provide the N2 gas. Here the conditions completely, yes, here we are having, right? Geldal method is not applicable to the following compounds. The first one, what will happen? Compounds containing nitrogen in the nitro group. If N2 group is present, the compound will not show, and nitroso also, right? In this form. Now compounds containing azo groups will also not give the Geldal method. Azoxy compounds, for example, azox means like this compound. Azoxy means this kind of N2, right? Nitrogen present in the ring also will not give, for example, pyridine. So this is a pyridine ring having the nitrogen. Quinoline also will not give the this test, right? So that is a major theory question will frame on the particular this 4 points, right? Now we'll see the question on this, how we can able to find out the question, right? For example, we have here the question given during estimation of nitrogen present in organic compound by Geldal method, ammonia evolved zero point 0.5 gram of the compound. That means weight of organic compound they have given 0.5 gram, right? Here volume they given as how much? 10 ml. Normality they have not given, but molarity they given 1. Here valence factor how much? 2. Why? 2 H plus ions will come from the acid, right? So then we have molarity into valence factor. So you can keep here 1 into 2. You will be getting the 2 is the normality. Take the formula percentage of nitrogen is equal to what we have. Tell me. 1.4 into then so then what happened? Normality. What is a normality? 2. What is a value? It will be 10 divided by zero point 0.5. Right? Here percentage we should not apply here. Here we should not percentage of multiply. Why? After calculation of everything only, we bought this relation. So how much we'll getting here? So we'll be getting here. Can cancel no point cancel out. Two table. So how much? 56 percentage is the percentage of nitrogen produced in this case. 56 percentage. That is given option is A is the right answer. Next, what happened? Curious method. Estimation of halogen by curious method. So in this case, we'll try to find out how we can find out the percentage of halogens, right? First, let us take. First, we'll see the process, how it takes place. Okay. So here what happened? Curious nothing but this experiment glass setup you have taken, that is called as a curious. A weight amount of organic compound is heated with a fuming nitric acid in the presence of silver nitrate. Wait, what? Organic compound containing halogen is heating with a fuming nitric acid in presence of silver nitrate contained hard glass tube is known as curious. So this is glass tube, right? Here we are having this one, right? Here black one will be the organic compound is there. That setup we are calling as a curious. The carbon and hydrogen present in the compound converted to carbon dioxide as well as water. Halogen present in the organic compound converted into halide, silver halide, right? The precipitate is washed and dried and weighed. We can get the percentage of halogen. Now we'll see in detail how to get this particular case. For example, what happened? So we have taken the organic compound, right? Organic compound we have taken, right? We are treating the organic compound containing halogen, right? This we are treating with a fuming nitric acid, right? Fuming nitric acid we are treating. So what is happening in this case? We are getting the sodium halide we are getting, right? Now this sodium halide we are treating with the AgNO3, right? So here silver halide is coming. Silver halide is coming. Now this silver halide will be the different cases we can able to see. First, for example, what happen if, right? If x is equal to Cl, right? See here, the curious method can be used to find out for the case of halogens, phosphorus, sulfur, right? Halogens here, X is equal to chlorine, bromine, iodine we can use. For this three metals, was three element. These three elements we can use the curious method to find out the percentage of this phosphorus, halogen or sulfur. Now, if X is equal to chlorine, we will get the AgCl precipitate. Now, AgCl, when you try to dissolve into the aqueous NH3, it is soluble complex will form. Now, if X is equal to Br, if you take X is equal to Br, AgBr will be forming. It will be in ammonia aqueous, sparingly soluble. It will be sparingly soluble, not that much of soluble. Now, when you take with this X is equal to iodine, so you get the AgI. So, when you treat with this ammonia, it will be insoluble, right? Now, if I want to find out the percentage of halogen, how I can find out? Simple one formula. Percentage of halogen is equal to, right? So, atomic weight of halogen, atomic weight of halogen divided by what we have, molecular weight of AgX into given weight of AgX divided by weight of organic compound into 100. So by solving this one, we will get the all types of halogens, chlorine, bromine, iodine. Okay, so this is how the process will be completed. Right. So here all the formulas are given, which will be for chlorine percentage, bromine percentage, and iodine percentage. So here clear diagrams also were provided. Just look at it, will be useful for your understanding for a theoretical question also. Now we have the question on this. A QES method, estimation of halogen present in organic compound, estimation of organic compound present in that. So how much? 0.15 gram of organic compound give 0.12 gram of HBr. Okay. Then find out the percentage of bromine. So what they given? Weight of organic compound they have given for us 1.15 grams. Weight of AgBr, how much they given? 0.12 gram. Right? Percentage of Br they are asking now. Right? Most important guys. Recently JEE also this question came on this. Okay. So percentage of bromine is equal to how much bromine weight? Bromine weight will be 80 by molar mass how much? 188. We can see here given clearly bromine percentage, right? Into weight of HBr 12 by 15 into 100. So after solving, how much we will be getting in this? In this, we'll get the 34.04 will get it. 34.04 percentage. That is option B is the correct answer for this question. Now, same here in this case. Next question for the case of chlorine percentage. So here, percentage of chlorine we can take here. Atomic weight of chlorine will be 35.5 and molar mass of AgCl 143.5 into 0.2870 by organic compound how much? 0.1890 into 100. So after solving, how much we will be getting from this case? Let us calculate how much we'll get it here. So 35.143.5 into 0.1890. Okay, 0.2870 into 35.5 divided by, so we'll be getting the 37.8 percentage. We are getting the answer. So option A is the correct answer is coming. 37.8 percentage we are getting. Okay, so now we'll see the last method. Then after we'll see the remaining, right? So estimation of sulfur we can see here. Estimation of sulfur, what happened? First, we'll try to understand the process. Same process as the previous one, right? Nothing will be different. Only compounds alone differ. Let us see here. A known mass of organic compound is heated in a curious tube with sodium peroxide or fuming nitric acid. Okay, fuming nitric acid. Now, with that, what happened? Sulfur present in a compound is oxidized to sulfuric acid first, which is then heat treated with the barium chloride. Solution gives a precipitate of BaSO4. In a BaSO4, we will find out the percentage of sulfur, right? Now we'll try to see how we can able to use it in a easy way to understand. So here what happened? So we have taken the organic compound, right? This one we are treating with the sodium peroxide or fuming nitric acid. Fuming nitric acid. Here what is forming now in this case? You're getting the H2SO4 will be forming. This H2SO4 if you treat with the barium chloride, what it will form? Tell me. It will be forming the barium sulfate. This is white precipitate be forming. Now, this will be washed and filtered. We can find out the percentage of sulfur is equal to atomic weight of sulfur how much? 32. By molar mass of barium sulfate how much? Barium molar mass is 137. So, let the 233 into weight of BaSO4 by organic weight compound into 100. So this is the case we can able to apply this formula. Okay. Now you can see the process how it will be taking place here, right? So here heat known mass of organic compound in a peroxide as well as HNO3. So here we are adding the HNO3 peroxide in the curious tube. Sulfuric acid is formed. After forming sulfuric acid, treat with the barium chloride. So you can see here precipitates are formed that is filtered and weight and we can find the percentage of sulfur. So here is the formula is there. We can able to calculate by using this formula. Now, chalo, check the answer question for this question for this particular concept. In sulfur estimation, 0.157 gram of organic compound give 0.4813 gram of barium sulfate. So given data, organic compound how much they given? 0.157 and weight of BaSO4 they have given 0.4813 grams. Percentage of sulfur is equal to how much? 32 weight of sulfur by molar mass will be 233 into so weight of BaSO4 48713 divided by 0.157 into 100. So after solving how much are you getting? So will we get the answer is 42.1 percentage. That will be the option. C is the right answer. So this is how we have to solve guys. This is how we have to solve. Okay, so thanks for watching, right? So remaining will continue further. Estimation of phosphorus, oxygen, right? Then along with that, we will try to solve some practice question which are most oftenly repeated in the questions, right? So most important questions we'll discuss, right? Next class. Okay. So thank you guys.